How do we construct sampling distribution of sample means? Before that, let us define what a sampling distribution of sample means is. It is a frequency distribution using the means computed from all possible random samples of a specific size taken from a population. To better understand this concept, let us have this example. Samples of 2 cards are drawn at random from a population of 6 cards numbered from 1 to 6. Construct the sampling distribution of sample means. To answer this problem, let us proceed to these steps. For the first one, let us identify the given. Remember that we are going to draw 2 cards at random from 6 cards numbered 1 to 6. Thus, we have our population, uppercase N, the population, we have 6, while N, the lowercase n, is the sample, the size of the sample. And now, let us proceed to step 2. We use the formula, the combination of our object taken n at a time to find the number of possible samples that can be drawn, wherein our uppercase N is the n object, while the lowercase n is our taken r at a time. And solving that, we have our solution here. Thus, when we want to determine 2 samples out of 6, there are 15 possible combinations using our formula. Now, this formula is very necessary, especially when we have larger samples. But in this case, we can just simply proceed to our step number 3, but it is better that we know how many possible samples we will have. Let us proceed to step 3. Now, for the next step, we list all the possible samples and the corresponding mean. Remember that we have 6 numbers, and we draw 2 out of the 6 numbers, and we have the possible samples. It could be 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 3, 2, 4, 2, 5, 2, 6, 3, 4, 3, 5, 3, 6, 4, 5, 4, 6, 5, 6. Now, these are all the possible samples, and we determine the mean of each sample. We have for 1, 2, the mean is 1.5. The mean of 1 and 3, the sum of 1 and 3 is 4, divided by 2 is 2. And we have 2.5, 3, 3.5, 2.5, 3, 3.5, 4, 3.5, 4, 4.5, 4.5, and 5 and 5.5. Now we have listed the possible samples and the corresponding mean. To be able to know the sampling distribution of the sample means, we proceed to the next step, which is we make a frequency distribution of the sample means. In this table, we only have 2 columns. The first column are the sample means, and the second column are the corresponding frequencies. Let us uncover this one. Again, we have the sample means 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5, and 5.5. Where did we get this? We got this from this table that we have. And again, we determined the sample means and we listed it here, and we determined the frequencies. How many samples have a mean of 1.5? We have 1. With a mean of 2, we have 1. With a mean of 2.5 is 2. With a mean of 3 is 2. With a mean of 3.5 is 3. With a mean of 4 is 2. With a mean of 4.5 is 2. With a mean of 5 is 1. And with a mean of 5.5 is 1. This table is already the sampling distribution of the sample means, because as the definition says that the sampling distribution of the sample means is simply the frequency distribution table using the means of all the possible samples. And we have it here. But remember that we have a random variable, and a random variable has a probability distribution table. The sampling distribution of sample means is also called the probability distribution of sample means. And to construct the probability distribution of sample means, we proceed to step 5. Now, as you can see in our table here, there are 3 columns. Again, the first 2 columns represent simply the sampling distribution of the sample means. We have the sample mean, the frequency. Now, we only add one column which we label as the P of X, or the probability of each sample mean. That is, the probability that the sample mean is 1.5 is 1 out of 15. We refer to the frequency to be able to get the probability. Because there are 15 possible samples, then we have our 15 as the denominator here. Again, the probability that the sample mean is 2, we have 1 out of 15. The probability that the sample mean is 2.5, we have 2 over 15. The probability that the sample mean is 3, we have 2 over 15. The probability that the sample mean is 3.5 is 3 over 15. In simplest form, we have 1/5. And the probability that the sample mean is 4 is 2 over 15. The probability that the sample mean is 4.5, we have 2 over 15. Sample mean is 5, 1 over 15. The sample mean is 5.5. The probability is 1 over 15. Now, we have constructed the probability distribution of the sample means.